In this video, you are going to learn how to find the acceleration of an object that is sliding down on an inclined plane, and the acceleration of the object that is sliding up on the incline. I have an object that is sliding down on an inclined plane. This angle is theta. Let us draw the forces acting on the object. There is force of gravity, which acts vertically downward. The normal force on the object by the surface, which is perpendicular to the surface. And there is force of friction, which is opposite to the direction of motion of the object. I put the x-axis along the inclined surface, and the y-axis perpendicular to the surface. This angle is 90 degrees. So in this right triangle, this angle is 90 minus theta. And in this right triangle, this angle is 90 minus this angle is equal to theta. The force of gravity is neither along the x-axis nor along the y-axis, so we need to find its x and y components. Let us draw the x and y components of gravity. This is the x component of the force of gravity, and this is its y component. In this rectangle, this angle is same as this angle. The magnitude of the force of gravity is m times g, where m is the mass of the object and g is the acceleration due to gravity. So the length of this vector is mg. This is the opposite side to this angle. So the x component of gravity is equal to mg times sine theta. The y component of gravity points to the negative y direction, so it is negative. And this is the adjacent side to this angle. So, the y component of gravity is mg times cosine theta. Next, let us find the normal force on the object. Note that on an incline, the normal force is not equal to m times g. To find the normal force, we apply the Newton's second law along the y-axis. On the y-axis, there are two forces, the normal force and the y component of gravity. Add the two forces, Fn minus mg cosine theta. This is the net force along y, is equal to mass times the acceleration of the object along y. Since there is no motion along the y-axis, the y component of acceleration is 0. So the right-hand side is 0. Solving for Fn, we get Fn is equal to mg cosine theta. With the normal force we can find the force of friction, which is equal to coefficient of kinetic friction times the normal force. Substitute mg cosine theta for Fn. Next we apply the Newton's second law along the x-axis to find the acceleration of the object. There are two forces along the x-axis, friction and the x component of force of gravity. This force is in the positive direction, and the friction is in the negative direction, so the friction is negative. Add the two forces, you get mg sine theta minus FFR. This is the net force along the x-axis, is equal to mass times the acceleration along the x-axis. Next, substitute this for the force of friction. All the terms have m, so we can divide the m out. And we get this equation. Since the y component of acceleration is 0, the acceleration of the object is just the x component of the acceleration. This is the equation for the acceleration. Note that there is no m in this equation. So the acceleration is independent of the mass of the object. Next we are going to find what is the acceleration of the object if it is sliding up. Note that an object can slide up on the incline if we give it an initial velocity when it is at the bottom. To find the acceleration, we need to do only one change in the equation that we just derived. Now the object is moving upward, so the direction of motion changes. The change in the direction of motion changes the direction of friction as the force of friction acts opposite to the direction of motion. So, Now the friction is in the positive direction. So we need to change the sign of friction in the equation. Change this negative sign to positive. This sign to positive. And this to positive. This is the equation for acceleration if the object is sliding up on the incline.